Right. So today topic is OCI Redis Cache. This is memory-based storage solution. So in my use case, customer is allowed to modify opt-in preferences from the portal. So this requirement is pretty simple, and even solution we adopted initially was very simple. But since it wasn't working, when we started getting number of calls. So what other solution we provided, we are going to discuss, like what was the caveat, what was problem statement, and then we will talk in details. So in this requirement, when I say about opt-in, I mean customer is allowed to set their opt-in. I mean how they are looking the communication, whether they are looking communication through email, they are looking communication through mail, notify, yeah, through SMS. All those things, opt-in was given to them. So they can make either get the update call that is happening from portal. So portal, they can enable, disable whatever opt-in they are looking. But integration team has to ensure whenever this page is loading, it is essentially to have the latest opt-in. And if we are not retaining the latest one, then it is the problem. So here in the problem statement, you can see uh, they can toggle the opt-in n number of time, and this was the problem in prod. So whenever they are setting some opt-in, I mean they are making this switch on and off n number of time. But we had some API REST limitation in Unity CX. So whenever we are receiving opt-in, we are calling this CX API, REST API, but that was not updating. Like that was not supporting if you are toggling very frequently. So we propose one solution. We brought this Redis concept in the middle, so that if somebody is making toggling very frequently, we are not hitting Unity CX. It will be in the middle. It will be in the memory, and after few minutes, we are sending all transaction to Unity. So this was the solution we have given for now. This is very, I believe, known solution where most of the people are aware about this Redis-based solution. So here you can see we have this layer. First one where client can make request through portal. In between we have Redis for storing any intermediate transactional data. And when they will make first get call, we are not going to have data. So we are going to get it from CX API. And if that is there, we will be taking from cache. And this is for update cache. Like if some update is coming, we are holding for a few minutes, and at last we are sending to database before this cache get expired. So here you can see we wrote some script to support this configuration. So we have config file. This is backup. You can ignore. This is the main file, opt-in Redis cache Python scripting, and we have used Celery file. So I will talk in details what Celery is about and what it is doing. So this application is very much scalable. So if tomorrow they are adding more number of customer, it is going to support. So here you can see in OCI, you can either configure this Redis over OCI, or you can set up this Redis over compute instance. So choice is yours. In this use case, I have set up this Redis over compute instance. So here you can see sudo su, and this is how I installed Redis over compute instance. And these are few commands that will help you to start stop Redis. So eventually when Redis will be started, you can see, you can run this command just to see whether Redis is up and running in your system or not. So we can talk about this file, opt-in Redis cache.py, that because that is the main file. So customer in the requirement, we have to build two operation get and update. Get, I mean, for getting opt-in data and update for updating opt-in data. And this is the request structure where if they are sending update, it will come all the data which opt-in they are looking, and we are holding in the middle in somewhere in the Redis cache, and at last we are updating. And this is the response we are sending. So let's talk about this Python script. So here, if you see this script, we have used Flask so that any external client can make this request. So you can see this update payload is for updating and get payload for getting request. So this get is pretty much simpler. We are forming the cache key based on it is source ID and source customer ID. And we are looking first in cache. And if it is there, we are returning back. And that is pretty much very fast, means potentially very fast because we are not looking data in the in system. We are just fetching from cache. So if it is not there, we are creating. So this is all about get. For update is little complex. So when we are getting update data, we are first forming the key, means cache key. You can see it is source ID and source customer ID. That because in my request, this is going to be common. So we are setting the time, like until what time this key will expire. So we are holding this for 5 minutes. So you can see that is in second, 5 minutes, 5 seconds we are holding. And at last we are sending to database like before this cache expired. So here you can see this call we are making. And this is JSON call where we are supplying this argument, I mean cache key. And how frequently we are making this is the countdown. So every 1 minute it is going to, we are enabling this task. So here if you can see we have used Slurry that is very much popular, like if we are going to have more number of customer, this will auto scale. So eventually how it will work, it will set up some task manager, and based on the request, it will enable some pool, and this pool will go up and down based on your number of customers. So here you can see when it is making this call, it is going to the other Python script, that is task.py. So I am coming there. So this is this task.py. So here you can see the salary task. So from there, every 1 minute, all the request will come here. And we have this token concept, like this is for making call to CX. We have to first acquire token, that is auth 2.0. And once we have the token, then we are calling this call to Unity CX. Otherwise, Unity CX will not accept that call. And this is all about salary task, how it works. So first, it is you can see a cache key it is forming, and it is holding for 5 minutes. And before it gets expired, it is acquiring token and calling this Unity CX API. So as soon as it will call, this request will be loaded to a database. So just think if user is toggling frequently, they would be getting data from cache. And before this cache expired, data is transmitting to Unity CX platform. So this is all we have done here. We have this cache config file where it is configuring the file. And this is for my test. I performed some test. So you can see we requested 1,000, and we have in the test script we have enabled some wait time, and the way it is written, like we have to ensure whether this salary task is working. We have enable auto scaling where like we hit more number of customers just to see how auto scaling is working. and you can see how it is scaling. So as the load gone up, you can see the task, how many task work manager it has opened, 1, 2, 3, 4, 5, 6. So this is how it works. So after deploying this solution, even though a client is make toggling frequently, but they are achieving their goal. So for now in this meeting, that's it. I will catch up in the next meeting. Thank you very much. Bye.